There is a massive, somewhat unsettling discovery rippling through the artificial intelligence community, one that challenges the very promise of creativity and diversity in the tools we use every day. A major research paper has just been published in October 2025 titled Artificial Hivemind: The Open-Ended Homogeneity of Language Models and Beyond. This comprehensive study comes from a collaborative powerhouse of researchers at the University of Washington, the Allen Institute for Artificial Intelligence, Carnegie Mellon University, and others. What they set out to analyze was something that many of us have intuitively felt but could never quite prove: the suspicion that despite the explosion of different AI models on the market, they are all starting to sound exactly the same. They wanted to verify if we are entering an era of a singular artificial mode of thought, and the results of their study are, frankly, startling. To understand the gravity of this, we first have to understand the methodology, because it wasn't just a matter of asking a chatbot to write a poem. The researchers constructed a massive dataset called Infinity Chat, comprising 26,000 real-world, open-ended queries mined from actual user interactions. These weren't yes or no questions, or math problems with a single correct answer. They were questions like write a metaphor about time, or brainstorm a unique marketing strategy, or explain the meaning of life. These are tasks where human creativity would naturally produce a kaleidoscope of different answers. The researchers then took over 70 different large language models, including the heavy hitters like OpenAI's GPT-4o, Anthropic's Claude 3.5, Google's Gemini, and Meta's Llama, and they asked them to generate thousands of responses. What they found is a phenomenon they have coined the artificial hive mind. The study breaks this down into two specific types of failure. The first is what they call intra-model repetition. This means that if you take a single model, say GPT-4o, and you ask it the same open-ended question 50 times, even if you turn up the creativity settings, it will stubbornly gravitate toward the same narrow set of ideas, phrasing, and structures. It creates an illusion of variety by changing a few adjectives, but the semantic core remains frozen. But the second finding is the one that should make every developer and researcher sit up and take notice. This is inter-model homogeneity. The researchers discovered that models trained by completely different companies using different datasets and different proprietary technologies are converging on the exact same answers. The most striking example from the paper illustrates this perfectly. When 25 distinct state-of-the-art models were asked to write a metaphor about time, you might expect a diverse range of literary imagery. Maybe time is a thief, a predator, a healing balm, or a circle. Instead, almost every single model, from the open source ones to the proprietary giants, clustered around one single concept: time is a river. A smaller, secondary cluster chose time is a weaver. That was it. Out of the infinite possibilities of human language and imagination, billions of dollars of diverse infrastructure converged on the same cliché. This leads us to the statistical reality of the situation. The researchers used embedding analysis to mathematically measure the similarity of these responses. They found that in 79% of cases, the average similarity between responses exceeded a score of 0.8, which is incredibly high. To put that in perspective, these models are often more similar to each other than two random humans would be. The paper suggests that this is not an accident, but a result of how these models are fine-tuned. The process of reinforcement learning from human feedback, which is used to make models safe and helpful, appears to be acting like a funnel, stripping away the weird, the unique, and the divergent, and forcing the models toward a safe, average, consensus reality. Now, let's talk about what this actually means for you, specifically if you are a developer integrating these APIs into your applications or a power user relying on them for work. If you are a developer, you might be operating under the assumption that you can engineer diversity into your application. You might think, I'll just turn up the temperature parameter in the API, referring to the setting that supposedly controls randomness. The paper, however, effectively debunks this. They found that Even with aggressive sampling settings, where the model is forced to take more risks, the semantic repetition persists. The model might use rarer words, but it is still saying time is a river. This implies that the creativity knob on your dashboard is broken. It changes the texture of the output, but not the substance. Furthermore, a popular strategy among developers is to use a multi-model router. This is an architecture where, if one model gives a poor result, the system queries a different model from a different provider, perhaps switching from GPT to Claude or Mistral to get a fresh perspective. The Artificial Hivemind paper suggests this strategy is far less effective than we thought. Because of the Intra-Model homogeneity, paying for multiple API providers might just mean paying double to receive the same answer rephrased. The researchers noted that the models from OpenAI and the models from Alibaba's Qwen family, for instance, had remarkably high similarity scores. If you are building a creative writing tool or a brainstorming agent, switching between these two providers provides almost zero functional diversity. However, the data did offer a glimmer of hope for developers willing to dig into the details. Not all models are equally stuck in the hive mind. The analysis showed that while the most intelligent and heavily aligned models like GPT-4o and Claude 3.5 Sonnet were the most repetitive, there were outliers. The open source model Llama 3.1 from Meta and Microsoft's 5.4 showed distinct semantic clusters in some experiments. In the metaphor test, while everyone else was talking about rivers, Llama and Phi were more likely to explore the weaver metaphor or other concepts. This provides a tangible, actionable insight. If your application requires true diversity of thought, you cannot simply rely on the smartest model on the leaderboard. You need to mix model families that have different alignment philosophies. Mixing GPT-4 with Llama 3.1 is statistically more likely to give you a broader range of ideas than mixing GPT-4 with Claude. The paper also highlights a critical trap for developers using large language models as judges. It is common practice to use a strong model like GPT-4 to grade the quality of outputs within an app. The researchers found that these judge models are biased toward Hivemind. They punish answers that are unique or divergent, even if humans rate those answers highly. If you are automating quality control in your software using LLMs, you are likely inadvertently filtering out the most creative and interesting data, reinforcing the very homogenization you are trying to avoid. For the general public, the implications are more philosophical but equally profound. We are facing a potential homogenization of thought. If we all use these tools to help us write emails, draft essays, or brainstorm business ideas, we are all drawing from the same stagnant pool of metaphors and concepts. We risk creating a feedback loop where human culture begins to mirror the flattened, average output of the models, losing the cultural nuances, the idioms, and the chaotic creativity that defines human expression. The paper warns that this could suppress minority perspectives and alternative worldviews as the models converge on a dominant, usually Western-centric mean. So, what can be done? Are there solutions? The paper is honest about the limitations. It is largely a diagnostic work, ringing the alarm bell rather than handing us a fire extinguisher. However, they did test a few technical mitigations. They experimented with a decoding strategy called mean p sampling, which is a more dynamic way of choosing the next word compared to the standard methods. While it helped reduce the most extreme repetition, the researchers concluded it was not a silver bullet. The mode collapse persisted in 60 to 80% of cases. For developers, the takeaway is that you cannot rely on the model to fix itself. You cannot simply prompt your way out of the hive mind by asking the model to be creative or think differently, because the model's definition of different has been trained out of it. The only robust solution today is to inject diversity from the outside. This means using retrieval augmented generation to force the model to look at diverse human-written documents before it answers, or imposing strict constraints that forbid the model from using its preferred cliches. Ultimately, Artificial Hivemind serves as a stark wake-up call, revealing that our smartest AI models are essentially excellent students who have all memorized the exact same textbook. They are reliable, coherent, and increasingly indistinguishable from one another. For the future of AI development, the challenge is no longer just making models smarter or faster, but figuring out how to make them distinct individuals. If you found this breakdown useful, please hit the like button and subscribe to the channel. I'm going to be doing deep dives into more architectures that are changing the way we build software. Thanks so much for watching, and I'll see you in the next video.